This is the Math 7 review for the first half of Chapter 1, 1.1 to 1.3. And we're going to first find the absolute value. So what we have to remember for this key concept is that absolute value is talking about the distance a number is from 0 on a number line. So if we have the first problem, the absolute value of -9, what this is really asking is how far away is -9 from 0? So -9 is 9 units away from 0. So our final answer would be 9. Not the absolute value of 9, just 9. So there shouldn't be any absolute value bars there. So our next example would be the absolute value of 7. Now a lot of students want to put -7 here, but remember we're talking about distance in absolute value, so we're asking how far away is 7 from 0. So again, the absolute value of 7 would be just 7. And the absolute value of -13. So how far away is 13 from 0? It is 13 units away. And that's all we need to do for absolute value there. You can use a number line to count how far away, or you can draw your own if you'd like. The next problems are completing the statement using the less than sign, the greater than sign, or the equal to sign. So our first problem says 6 and then the absolute value of -6. So we're comparing these two numbers. So what I like to do first is go to this absolute value here and actually solve that part of the problem. So the absolute value of -6 is asking how far away is 6 from 0, and it is 6 away. So now we're comparing this regular 6 here and the 6 we just calculated. And since that is the same number, we're going to put an equal sign there. Our next problem says 9 and then the absolute value of 7. So again, I'm going to solve this absolute value part. So now I'm comparing 9 and 7, and 9 is greater than 7. And then lastly, we have the absolute value of -11 and 10. So the absolute value of -11 is saying how far away is -11 from 0, and that is 11 away. So we're comparing 11 and 10, and 11 is greater than 10. Okay, our next problem say order the values from least to greatest. Here, this is where you need to use your original form. So for example, our first problem has a few problems in there, or few numbers in there, that have absolute value bars, which is the absolute value of -5 and the absolute value of -4. So before we put these in order, I'm going to find the absolute value of both of those numbers. So the absolute value of -5 is 5, the absolute value of -4 is 4, and now we're going to put these in least to greatest order. So the smallest number is going to be this -6, then -4, then we would have our +3. And then next in our list would be this value of 4, but its original value is the absolute value of -4. That's its original form. The value of that is 4, so we're going to put it in the order of where 4 would be, but we're writing it in its original form. And then the same thing goes for the absolute value of -5. So that would be in order least to greatest. Our second problem, I'm going to do the exact same process. The absolute value of -15 is 15. The absolute value of -9 is 9. So then this order would start with -10. And I like to cross off my numbers as I do this. -8. Make sure I don't forget any. Then we have the absolute value of -9. Then we have 12. And lastly, the absolute value of -15. And we have used all of our numbers. Our next problems are just simple addition problems. We make sure we follow our rules for addition. So our first one, since these have the same sign, this -3 and -8 have the same sign, our rule says to add the values, 8 plus 3, which is 11, and then use that same sign. So our answer is just -11. Our next one here, there are different signs. So we take the larger number 16, and we're going to subtract 4 from that, which we have 12. And then we use the sign of the bigger number, and 16 is positive, so our answer is 12. Another way you can do this, if you want to draw out your integer counters, and if you have 16 positives, (14, 15, 16, and we have 4 negatives. For every one positive, there is a negative that cancels out. So we cancel out 1, 2, 3, and 4, and we're left with 12 positives. So you can always draw a picture for those as well. Now we have a few subtraction problems. Our first one is 3 minus 9. You could start at 3 on the number line and take 9 away from it. And if we count down from 3, 9 spaces, we would end up with a negative 6. And our next problem, negative 5 minus a negative 5. So I see these two signs right next to each other, and we know that together those make an addition sign. So now we have the problem, negative 5 plus 5. Those are opposites, and we know that when you add opposites together, you should always get 0 as your answer. Okay, now we're getting into some word problems. So here it says the table shows the income and expenses for a school carnival. The school's goal was to raise $1,100, so this is extremely important. Did the school reach its goal? Show your work. That's huge there. Show your work. So we need to make sure that the school reached their goal. So we have all the money that they earned on all these different carnival games or concessions. So $650 for games, $530 through concessions. People donated $52, but they lost $28, or they spent $28 on making the flyers, and they used another $75 for decorations. So there's a few ways we can do this. I'm actually going to add up all my positive numbers first. Combine all those together. So when we have the sum of these three, we would get 1,232. And then I'm now going to add up my negatives. So I'm thinking same sign. If I add those two together, I'm just going to add up the values, 2875. And then I'll use the same sign of both of those. That same sign would be negative. So this will be a negative answer. And we end up with 103. So this is a negative 103. So what we can do here now is we can take 1,232 and subtract the amount of money they had to spend to do this, which is $103. So once we get this final difference, 12 minus 3 is 9, 2 minus 0 is 2, 1, 1. So did the school reach their goal? If they raised $1,129 and they wanted to reach 1,100, the answer would be yes. So the answer is not just this value here. It's making sure you answer the question, which is a yes or no question. This work just supports your answer. And then lastly, it says temperatures at the Gobi Desert reach negative 40 degrees Fahrenheit in the winter and 90 degrees Fahrenheit in the summer. Find the range of these temperatures. So the range is going to be the distance between these two. So if we think about this like on a number line, which I'm not going to draw an exact one, but if we're at negative 40 here, degrees Fahrenheit, and 90 degrees Fahrenheit here, we want to find how far apart those two numbers are. What's the distance between this negative 40 and 90? So it takes us 40 units to get all the way up to 0, so that's 40. And it takes us from 0 to 90, 90 units. So we can just add these two together, 90 plus 40, and we get 130 degrees Fahrenheit. Make sure you always label your answer. So this concludes the review for our 1.1 to 1.3 quiz, first half of Chapter 1 for Math 7. Good luck!